So if we take 0.9 bar, can we actually compare it to 1? Because it is a quite different value. I mean, it is an infinite number of 9s and they go on. But is it really equal to 1? Because the difference between them must be 0.000 and it goes on forever, and at the end you reach a 1. So we can approach this using variables. So if we have a variable x, we can set it to 0.999, which goes on forever, which is equal to 0.9 bar. And then we can take 10x, which will just be this multiplied by 10, so it must be 9.9 and it goes on, which is 9.9 bar. And if you take x, which will be 0.9 so on, and you subtract it, you must get 9x, which is equal to 9 in this scenario, because 9 and 9, these cancel out when you subtract them because they're infinite. And if we divide both sides over here by 9, you should get x is equal to 1. Now this does seem pretty counterintuitive, but we can explain this using the concept of limits, because as x approaches 1, so when it's 0.99999, it is so unfathomably close to 1 that we just say it's 1, because the difference between 1 and this will be 0.000 and then 1, and that is the smallest possible value we can conceive. So technically that is just 0, because when we use limits for graphs, like let's say if I have a 1 by x graph over here, and if I want to say limit of x approaches 0, 1 by x, eventually I will land on infinity, and that will when I get the smallest value of x, that is not 0, and that will be this value. So technically we can compare 0 and 0.000 goes on forever and then 1, making the proof knowledgeable and sensible.